Okay, call recording is on. Hopefully you can hear me, right? Everyone raise their hand.
Ken.
Okay.
Yep, Ken, we can hear you. Thank you.
Great. All right, it's working. That was the one thing we worried about. I'm calling in via phone. So yeah, a little different scenario here for this presentation. Was hoping to do it in person in Reno, even though there are we would have seen a good round of thunderstorms yesterday probably too if we were there, or at least over at Tahoe. Pretty active day weather-wise here. So I had to retool my briefing a little bit and make it just some screen grabs because we noticed quickly yesterday too, not good for video or for showing live web pages. So maybe next time I'll get to go more into the web pages and show some neat stuff that you can do with the AWC page and various other aviation useful pages that are out there and some of the things that we use. Until then, I will talk a little bit about our operations here at Oakland Center. Oakland Center, we're kind of divided into two sections. We have the oceanic and the domestic. Oceanic's ICAO designator or FAA designator is a ZAK, and domestic we're ZOA. Domestically, there's 21 centers. We are the largest airspace in the world. We control aircraft over the entire Pacific Ocean. So with that, we routinely have to deal with monitoring of volcanoes. And a lot of these volcanoes don't make the news because they're in areas that are not populated, but they definitely have impacts to air traffic, and routinely sometimes too, something we have to constantly monitor. Tropical cyclones and hurricanes. We go across the 180 date line for the Western Pacific, we call it, and we also have to deal with severe turbulence. We also focus here domestically on SFO operations because of their impact to the NAS, the National Airspace System. And it just takes one cloud over the approach for San Francisco to reduce the rate in half for the arrival rate. And so ground delay programs are routine as well. Next, I'll talk a little bit about some case studies. Low-level wind shear turbulence setup for the Bay Area. Reno does a great job in their tasks for putting low-level wind shear there on top of it. They really know the situation there. We look to them for their expertise. For conditions for the Reno area, our TRACON, NorCal TRACON, works a lot with the Reno airport and will relay a lot of the pilot reports to Oakland Center here for aircraft flying into Reno. I'll talk more about PIREPS next too, and also a case study for a jet stream severe turbulence wind event. And then I'll mention a little bit about Twitter in the CWSU realm. Not all CWSUs are active on Twitter, but many in the western region are. All of them are actually. And you can glean a lot of good information from looking at some of those Twitter feeds that we actively engage in. So I mentioned we're the largest airspace in the world. Here's domestically ZOA compared to the other 21, Anchorage being the next largest center. And we have to deal with multiple National Weather Service Forecast Office warning areas at the surface. And here is how it's divided up oceanic-wise for the Pacific. Our oceanic controllers do have concern for any active advisories on our borders. So we have quite a few different national borders, bordering FIRs from Tahiti. Especially for Tokyo, Fukuoka, we deal with them a lot because they are actually responsible. They're volcanic ash advisory center. For Kamchatka, which is where we actually had some active volcanoes this morning. It just ended. So we're monitoring for jet streams that would take the flow, especially like today they have a strong northwest flow. So it's taking anything that we see this often for any major eruptions over Kamchatka. There's some main active volcanoes up there, but the strong northwest jet stream will take it right across Anchorage and into Oakland Oceanic FIR realm. Case in point over Anchorage, this was in January of this year. Came out. This one, sometimes they can erupt out of nowhere, and Sheldon hadn't erupted in years, and major eruption, and in 18 hours the plume was almost into Canada, that definitely impacts the traffic from CONUS to Anchorage and oftentimes some of the North Pacific tracks. I will mention that our traffic management unit here at Oakland Center, actually, they are the ones that produce the North Pacific tracks, the daily tracks, through their DOTS Plus system, it's called. They negotiate the westbound traffic with Tokyo, who do the eastbound traffic. And the reason that we have various tracks over the North Pacific, because of the high winds and the variability in the winds, their system will try to avoid headwinds as much as possible for efficient flow of traffic. But it does not take into account weather. So on this day, if there was a strong jet stream into the southern portions here of the North Pacific, it would probably try to take them to the north and right into that volcanic ash, which we don't want to do. We also have to deal with tropical cyclones, and in this case, a hurricane in the East Pacific and moving off to the northwest, threatening Hawaii. And Hawaii doesn't want to deal with that too much either. They don't often have to, but this was a recent case last year, I believe, where they had one moving close to them. We also have to worry a lot in the Southwest Pacific, especially in the autumn time of year. And then locally here with San Francisco, we have some neat stuff. We have a good look out the window for that one cloud that's going across the approach and threatening for the ground delay program, from which they will build the ground delay program to the time that we say it's going to clear. So no pressure on us on a daily basis. We have 2 new ones, and we're looking to get 2 more right now, and we also are working with FAA weather evaluation team and NextGen for possibly more cameras, and also in talks with if there's any familiarization out there with the Alaska webcam network and trying to get more at airports in the U.S. Very useful. So here's a case study for volcanic ash over the North Pacific. I am going to show some PIREP information with this, but in this case we had Sheveluch, which actually was Klevshevskoye last evening, that went up to 23,000 feet and went into Anchorage airspace, but since dissipated. And this day, November last year, major eruption, strong winds took it well into, and so we're looking at Tokyo has it. Once it moves into Anchorage, Anchorage has it, and once it moves out of Anchorage, it goes into our airspace, and that's controlled, that's forecast by the Washington VAC. We call it the VAC, the Volcanic Ash Advisory Center. They issue the volcanic ash advisories, which go out to 18 hours. The SIGMETs, though, only go out to 6 hours. So the SIGMETs will show only up to 6 hours. For our purposes here, often, especially for the North Pacific tracks, we're looking at the 12 to 18 hour point. So we are constantly looking at the 12 to 18 hours where the ash is going to be, because that's when the aircraft will be flying through that region, that threat region of potential volcanic ash activity. And sometimes there is a SIGMET that is active, and sometimes the aircraft will try to fly through it. And in this case, we do get some good verification, often, in a SIGMET when someone tries to fly through it, whether it be severe turbulence, and in this case, volcanic ash. Clear skies, I assume, and they were able to see the volcanic ash around 33 to 34,000 feet. But, again, PIREPS are very good information to verify a product, and also, in this case, the flight levels of encounter. You can see here there's also a tropical cyclone active just east of Guam. This was in November last year. Case study for Bay Area, low wind shear event. We do get them often up in Reno. In this case, we'll see a little bit set up for the Bay Area. These were a lot of the pilot reports. You can configure the AWC webpage to look like this. You can make the pilot reports a little bit bigger. And we often like to monitor or at least I do, I like to monitor at least 3 hours worth of PIREPS. Sometimes, I think the default is for 90 minutes worth. In this case, there was a lot of some low wind shear reports, but most of it was elevated severe turbulence above 1,000 feet and up to around 2,800 feet for the severes in the South Bay. And this is what it looked like that day. It was clear all along the coast, clear everywhere, VFR. Here's the TAF, just a few high clouds. And then look at the winds. They're very light. If you were just going by what the TAF was saying, probably not a good idea to be trying to decipher turbulence with that. It's going to be nice at the surface, but everything was just above the surface. In this case, we had a strong northeast flow. We often look at not just the surface conditions, but we're looking at some of the RAWS sites. The RAWS are the remote automated weather systems that are put in place for fire weather support. Here's the station plots. The reds are the gusts, and the RH, the relative humidities, are in green. And so you see around Mount Diablo at over 3,000 feet, we have gusts at 23, and RHs were pretty dry at 30, and into the Bay Area when this screen capture happened. We had some pretty good north to northeasterly flow. Telltale sign, often same thing happens in Reno area. What we look for is something mechanical going on with the turbulence, creating some heating and some drying. And in this case, you can often see it in the temperature and dew point and RH trace. In this case, at 11:30 a.m. at SFO, northeast winds just above the surface, but very light and variable at the surface. And the temperatures went from 63 with an RH of near 70% to a couple hours or less than an hour later, it was down to 22% RH. You can see the temperature and dew point spread there, what we call it. And in that case, we had that, you saw those turbulence reports that we had. Another thing to track in on is I wanted to highlight are the discussions, the aviation or the forecast discussions from the forecast offices. On this day, just looking at the TAF, like I said, didn't show too much. Very light winds at the surface. In this case, though, it was mentioned. We're looking at the pressure gradients often. Sometimes some of these discussions can get some people like them for they get into the weather speak at times. But in this case, if you were looking at this, it was talking about this strong offshore flow with gusts up to 55 miles per hour over some of the hills. In this case, the Monterey Bay area, their aviation discussion did mention stronger northeasterly winds forecast, resulting in potential some low-level wind shear, which we did have. In this case, wind shear on final possible, and we had it in the South Bay, near Reed Hill, starting around 17Z is when we started getting the reports. Aircraft were verifying that it was there. We had severe and some moderate to severe, but it wasn't at the surface, and it wasn't really plus or minus. It was elevated at 2,600 and 3,500 feet, moderate to severe, reported by multiple aircraft in this case. That led to the issuance of a center weather advisory, low wind shear possible, but the main turbulence was from 1,000 to 4,000 feet, and then after that we had a few more reports too, some moderate to severe and some moderate, elevated again from 2,000 to 2,800 feet. Okay, and not sure how I'm doing on time here. We're doing good. Sarah said, all right, good. Here's a case where we have the jet stream. So I just want to show the scenario. I just wanted to mention, too, jet stream, the meteorologist, or at least the way I look at it, when I see the jet stream winds, that is energy. You got strong jet stream aloft, oftentimes that equates all the way down to the surface. Sometimes it doesn't, but oftentimes it will. In this case, you would definitely expect it, especially in the higher terrain and elevation areas. Whenever you have a trough coming through, and elevated winds happen over the terrains of the Sierras especially too. In this case, we had indicated between 140 to 160 knots in the southwest ZOA, the jet stream aloft. This is the jet stream at around 30,000 feet. In this case, here's a pilot report. This is an automated report. We look at those too, an air rep from a United flight. In this case, it was mentioning and verifying that indeed we had southwest winds, but they were at 180 knots verified. So the models were actually a little bit low on their estimation of these speeds, so lots of energy. And you can see what happened this day with the widespread turbulence reports throughout ZOA trough, and also with some precipitation and icing as well. And finally, Twitter. Sarah will get a chance to talk more about that. I want to steal her show, but Very useful information can be gleaned from Twitter feeds from various forecast offices. Like I mentioned, that ZOA, CWSU, we do have some of our information in our Twitter, and sometimes we're busy. We can't constantly, we don't have a dedicated social media person, but we can look around and share stuff, like from Reno. They put out some neat stuff often and give you a heads up on the lenticular clouds out there. I can't play this as just a screenshot, but this is a day where we shared the Reno post indicating the gusty winds and lenticular clouds over the Sierras. Another one, this one got over 500,000 views, was the Kincaid fire from last year, and we modeled up some of the data for the smoke, and sure enough, the smoke did blow south into the Bay Area the next day, and we had ground delay programs for San Francisco as a result because of the reduced visibilities. And one last case of just showing you what happens over the Pacific too, where we get reports for verification, and also sometimes we'll see the indications are there. We are talking with AWC, who issues for segments for this region. In this case, we had a slew of moderate to severe reports, and this oftentimes these PIREPS will lead up to the issuance of a segment. And that is all I had. The going story for San Francisco and the forecast for it for us for the clearing for San Francisco is every once in a while our camera will spot a raven, and usually that's a bad omen for us, so we have to add 2 hours to our forecast.
All right, thank you, Ken. It looks like we do have one question here, and the question is, do you feel the FAA is willing to fund more tower cameras elsewhere in the CONUS? The Alaska network is amazing, and it would be nice to see that duplicated.
Yeah, thanks for that feedback, and that is ongoing right now as we speak. I've actually been in discussions with the person in Alaska, and we have lots of, in fact, my office owns the 2 cameras on top, and I'm already talking with at least the local forecast office in Monterey to get 2 more, and I'm also in talks with San Francisco management who support even more in getting us access to some of their existing ones as well. And that is getting the attention from others too in the FAA. Right now we are in talks of hoping to, and hopefully maybe we'll be the trial place to test it out, but it's proven here already at San Francisco how useful the webcams are. And one of my inputs too, I noticed in other regions like in Canada and even in France, they actually will have the web camera up, and like I mentioned in our last meeting with the FAA, I said a picture is worth 1,000 words. Inscribed onto the image, the current image of what the camera sees is the METAR. So oftentimes, you know, the METAR will say few are scattered, at least for the ASOS, because the ASOS is just looking straight up for about a 5-minute average. But we can see the ceilings moving in on the cameras. So oftentimes you'll get a heads up before what the ASOS is even saying. So it's very useful, and even have an archived. That's one of our best practices too. Is we have archived images where you can see the clearing today compared to the previous day and see if we're more advanced or not and ahead of schedule. So.
Very good, thank you. And then looks like we have a comment from Polly's at the NTSB. The FAA is in the process of adding weather cameras in Hawaii in pilot, weather, and mountainous regions, common flying routes. The plan is to expand that to Western CONUS as well. And I believe the install in Hawaii is already going on this year. Sites have already been picked. And then I also added a link to the Alert Wildfire page. Now, this is not necessarily at airports, although some of the cameras do point towards airports, but it is a vast network of cameras that tend to be on mountaintop sites and pointed in various locations. They are for fire detection, but they are also incredible resources to be able to see the sky, to be able to see how elements are changing. If you see mountains start to disappear, you know that you're going to be dealing with mountain obscuration. And some of the cameras are actually pointed at airport locations. I know personally, being in Reno, we're able to see South Lake Tahoe at times, the Truckee Airport through the Martis Valley at times. We can see, we see the Reno Airport out of our window, but we can also see it using the webcam imagery as well. So check out that link that I just posted. It has a lot of great cameras to be able to see what's going on.